excuse me, run through the problems. I did number 1 yesterday. Is that correct? The main thing you have to remember, and I have to always go back to it because I can't remember it. So the P value is the Y value, and the Q is the X value. Okay? So they want, it says the demand function for the sale of widgets. Back to the widgets. We can't get creative. We have to.
What page, sorry?
Business calculus, applications in business, profit, revenue, cost with quadratics.
Oh. Oh, for number 2, sorry.
Yeah. Oh, yes. We got more peoples.
You guys missed the worm.
Yeah, I missed it. You'll have to catch it during the assembly tomorrow. And if Dwyer doesn't go to the assembly, I got a chocolate milkshake during this period. Or a coupon for a free tattoo. All right, so you guys ready? We good to go? All right, so the demand function for the sale of widgets is given P times quantity Q plus 4 equals 400, and the supply function T minus Q minus 38. Find the market equilibrium of this. Okay, I guess we could do that. So we're going to go Y X plus 4 equals 400, and we'll graph that on what's called Desmos. And then 2P minus X minus 38 equals 0. So let's graph those. Or Starp will graph them, and you guys get to watch and play games. Best day ever. All right. Desmos. Graphing calculator. All right, first equation, y x plus 4 equals 400. And then we have 2y minus x minus 38 equals 0. All right. I'm not seeing graphs. Oh, I see some graphs. There we go. All right. So we got some goofy looking graphs here, but you can find the market equilibrium. I would just be able to identify those 2 points, and negative 54 comma negative 8, which wouldn't make sense because you're not going to produce negative 54 items. Okay, but 12 comma 25. But if you list both the answers, you're going to get this kind of stuff correct. Okay, so that's number 2. Problem number 3, suppose that a monopoly market, the total cost per week of producing high-tech widgets is C equals 3600 plus 100x plus 2x squared. Suppose further that the weekly demand function for the price of the product is that. Okay, P equals that. Find the number of units to break down for break even. I think I could do this. You have faith in me, friends? All right, so C at X is Y equals 3600 plus 100X plus 2X squared. And then Y equals 500 minus 2x. All right. Oh, purple line. Looking for the green. Uh-oh.
I was also I was very confused.
I don't think there's any more turning points that are taking place. So, what is the only thing that you can conclude? Do they cross each other?
No.
Is there a market equilibrium?
No. Okay.
Can't be done.
So
I hate when math proves an or shows an impossible event.
Would the answer both A and B then be just like impossible?
Oh, I don't know. I didn't even read them. A, find the number of units that will break even. Can't do it. What should be the selling price of the widget to break even? Can't do it. Okay. Oh, shoot, I'm on the wrong page. All right. Problem number 4. Suppose a company has a fixed cost of $28,000, variable cost per unit of 2/5 X plus $222, where X is the total number of units produced. Suppose further that the selling price of the product is $12.50 minus 3/5 X per unit. Okay. All right. I think we can do these. I tried to do a little tricky on you, but you have to realize, oh, I can go y equals 2 divided by 5, x plus 222. And then I can go y equals minus 3 divided by 5, x. All right. Suppose a company has a fixed cost of 28,000 and a variable cost. Suppose further selling price is that many dollars. What do I want to do with that? Dude, I got a text. Yeah, baby. That's good. It's for my band. They said they're willing to play tomorrow. Where do I want to go with that 28,000 though? It's fixed cost, variable cost. I think I don't know. I think if you get to this point, you're fine. So that's your break even. Find the maximum revenue. I wouldn't worry about B. Find the profit function from the cost revenue. So profit is cost minus revenue. Cool. And then I'm not worried about number 5. So so being that you guys are choosing to do what you're doing, can I wow you with something to inspire you?
Sure.
So I would bet you, y'all have done this at least once.
Oh,
You know, when you're bored in class and you forgot your phone, you might draw this. Agree?
mhm.
So talk to me. What do I really have drawn up there?
2 squares and some lines.
2 squares and some lines. What is it trying to represent?
Cube.
A cube. So I tried. Does everyone feel comfortable that this is a 3-dimensional object? Now, friends, if you stare at this point right here, make that point be the back corner and the front corner, then the back corner and the front corner. Is the cube flipping back and forth on you?
I can get it to flip once and it always stops for me.
Okay. So that is a 3-dimensional cube represented on a 2-dimensional space. Agree?
Mhm.
So does everyone feel comfortable you could find something that is that shape someplace? Okay. Paste. All right. Let's move this over here. So now I have the identical cube right here. Agree?
Mhm.
All right. Ready? By definition, my friends, this is a fourth dimensional cube represented in two space. Okay. Let's go further, just because we can geek out. All right. This would be a good color. Orange. Go with that. Friends, guess what this is? Any guesses? Yep. But problem is, friends, so then I have to connect all of these particular vertices, and I'll do these as well over here. Then I have the subvertices I have to do. Because 5D, we got to travel back and forth between 4D and 3D and 2D. All right, now it's going to get messy. All right, I'm going to go with this to this.
It looks like you have a really good design for a spaceship.
I'm in. Everything we keep intercepting each stuff. Okay, where do I go there? And then I have to get all the pinks are going to it, and then I have all these. It doesn't matter if I twist them because those are becomes. So basically, there's all kinds of things that take place. So that's basically what a fifth dimensional object drawn in to represent a fourth dimensional object represented to look like a third dimensional object drawn on a two-dimensional space. So can I actually see what the fifth dimensional object looks like? No. Can I see the fourth dimension? No. I can see the third dimension. I just can't see. So basically, each dimension you improve that, it starts getting crazy. The lines don't have to intersect each other to the same vertices. They can go to separate vertices, which in theory, in the world of physics, is where we can start defining why certain things take place in our universe as we improve the dimensions. What does this have to do with business? Not a thing. Cool. All right. So, what do we say we do? Business calc. Worksheet 2.3. You guys want a whole lot of homework? Yeah, that'd be awesome, Stuart. Best day ever. What do you say we have problem 1 and problem 2? Deal?
Okay.
And now